Hey everybody. We are going to start today with our unit on sequences, and eventually we're going to get into series as well. So sequences we're going to talk about in today's unit are basically going to be a list of terms, and with series we are going to take the sum of the terms of a sequence. Okay, so sequences we list terms, series we wind up adding terms together. And we're going to take a look at some special types of sequences and series. In today's lesson, we're going to look at like a lot of terminology that we're going to see and some notation that we're going to use involving sequences. And then we're going to look at later on in this unit some special types of sequences and series, namely arithmetic sequences and series and geometric sequences and series. And we're going to talk about the differences between arithmetic sequences and geometric sequences, and arithmetic series and geometric series. Okay, so to start with, we're going to go ahead and define what a sequence is. So a sequence is defined as a function whose domain is the set of positive integers. Okay, so we're going to have like a formula that we can use to generate all of the terms of a sequence. And we get the terms of the sequence by plugging positive integers into that formula. So this is new for you guys maybe. My son is yelling in the background, so my apologies for that. But you may have to bear with that as we move through today's lesson. Okay, so with sequences, they are usually expressed by listing values in order. So one way that we can represent a sequence is to like list the terms of the sequence. So for example, we could have a sequence containing the terms 1, 1/2, 1/3, 1/4, and so on and so forth, where we just list the terms of that sequence. Another way that we can represent a sequence is by writing the formula that generates all of the terms of the sequence. So it can also be represented by placing braces around the formula for the nth term. So if you take a look at the sequence that we have listed above here, so this is going to be the one that I highlight up here, we can write the formula that generates all of the terms of that sequence. So that sequence is going to be the sequence a sub n, which we have inside of set braces. And then the formula, which we're also going to write inside of set braces that generates all of the terms of that sequence, is the formula 1 over n. Because if I start plugging positive integers into that formula, when I plug 1 in first, 1 over 1 gives me the first term of the sequence 1. When I plug 2 in next, 1 over 2 gives me the next term of the sequence 1/2. When I plug 3 in next, that gives me the next term 1/3. When we plug 4 in, it gives me the next term 1/4. And that's going to give me all of the terms of that sequence. Okay, so we're going to do some examples then involving sequences. So the directions for this first set of examples ask us to write down the first 5 terms of the sequence. Okay, so there are a couple of ways you can do this. I'm going to go ahead and just like list the terms here down below, and then once I've simplified everything, then I will actually like write down the first 5 terms of the sequence next to the sequence itself. So for number 1, we have the sequence generated by the formula 2 to the n power divided by n squared. So when we plug 1 in the place of n for our first term, we get 2 to the first power, which is 2, over 1 squared, which is 1, and 2 divided by 1 simplifies to 2. Okay, for the next term, a sub 2, we're going to plug 2 in the place of n. So that's 2 squared, which is 4, divided by 2 squared, which is also 4. 4 divided by 4 simplifies to 1. The third term, a sub 3, we get by plugging 3 in the place of n. So that's going to be 2 cubed, which is 8, divided by 3 squared, which is 9, and that is 8 over 9. A sub 4 will be 2 to the 4th power, which is 16, divided by 4 squared, which is also 16, and 16 divided by 16 simplifies to 1. And then for the last term, a sub 5, we get 2 to the 5th power, which is 32, divided by 5 squared, which is 25, and 32 over 25. We can't simplify that at all. So if we list the terms of that sequence, the first term is 2, second term is 1, third term is 8 over 9, fourth term is 1 again, and the fifth term is 32 over 25. Okay, and then I'm going to put a comma and then 3 dots at the end just to indicate that that sequence is going to continue on. Okay, so I'm going to have you guys do the next 2. Okay, so I want you to go ahead and pause the video here and then work the next 2 out. And then once you had those completed, you can go ahead and turn the video back on to check your work for those 2 problems. Okay, so let's take a look at number 2. So the first term, a sub 1, we're going to plug 1 in the place of n. Okay, so when I plug in 1, we get negative 1 to the first power, which is negative 1. And then 1 plus 3 is going to be 4. And then our denominator is going to be 1 plus 2, which is 3. And negative 1 times 4/3 is negative 4/3. For a sub 2, our second term, we're going to plug 2 in the place of n. So that's negative 1 squared, which is 1, times 2 plus 3, which is 5, over 2 plus 2, which is 4. And 1 times 5 over 4 is 5 over 4. For our third term, a sub 3, it's going to be negative 1 to the third power, which is negative 1. And then 3 plus 3, which is 6, over 3 plus 2, which is 5. So that winds up simplifying to negative 6 over 5. For the fourth term, a sub 4, it's negative 1 to the fourth power, which is going to wind up being 1. 4 plus 3 makes the numerator 7. 4 plus 2 makes the denominator 6. And that simplifies to 7 over 6. And then a sub 5, negative 1 raised to the fifth power is going to be negative 1. And then 5 plus 3 is 8 over 5 plus 2, which is 7. So that winds up simplifying to negative 8 over 7. So when we list the first 5 terms of this sequence, it's negative 4/3, 5 over 4, negative 6 over 5, 7 over 6, negative 8 over 7, and then again I'm going to put 3 dots at the end to indicate that that sequence is continuing on. Again, we're just identifying the first 5 terms of the sequence. Now, this sequence, when you look at the terms of the sequence, we see that the terms alternate, where the first term is negative, the second term is positive, the third term is negative, the fourth term is positive, and the fifth term is negative. So if terms alternate from negative to positive or positive to negative, that sequence has a special name. And the name of that sequence is what is called an alternating sequence. Okay, so an alternating sequence is a sequence where each term alternates from positive to negative or negative to positive. Now, something to keep in mind with alternating sequences, and we're going to use this in a later example, is if your first term is positive, that alternating sequence is going to have a factor usually of negative 1 raised to the n plus 1 power. Because if you think about it, if the first term is positive, if I plug 1 in the place of n in that formula, that would be negative 1 raised to the second power, and that's going to make that first term positive. Okay, if the first term is negative, you will often have a factor of negative 1 raised to the n power. Because if I plug 1 in the place of n in that formula, we're going to get negative 1 to the first power, which negative 1 to the first power is negative 1. And usually that's going to give you a negative value for the first term in that sequence. And when we look here at that formula, we do have -1 raised to the n power. So that first term is in fact negative here. Okay, so when we do the same thing for number 3, our first term b sub 1, we're going to get by plugging 1 in the place of n. So the numerator is going to be 2 to the first power, which is 2. Denominator is 3 to the first power, which is 3, plus 1 is 4. 2 divided by 4 simplifies to 1/2. When we find the second term, b sub 2, that's going to be 2 squared, which is 4, over 3 squared, which is 9, plus 1, which makes that denominator 10, and 4 over 10 simplifies to 2/5. Our third term, b sub 3, would be 2 cubed, which is 8, over 3 cubed, which is 27, plus 1, which is 28. And both 8 and 28 are divisible by 4. So 4 goes into 8 twice, 4 goes into 28 7 times. So that third term winds up simplifying to 2 over 7. Our fourth term, b sub 4, would be 2 to the fourth power, which is 16, over 3 to the fourth power, which is 81, plus 1, which is 82. And both 16 and 82 are divisible by 2. So 2 goes into 16 8 times, 2 goes into 82 41 times. And our fifth term, b sub 5, would be 2 to the fifth power, which is 32, over 3 to the fifth power, which is 241, plus 1. It's 243 plus 1, which is 244. And then both 32 and 244 are divisible by 4. 32, when we divide 4 into that, goes in 8 times. And 244, when we divide 4 into that,